Marine scientists call it the ocean's twilight zone, where only a small amount of sunlight can penetrate. But it's the ocean life here, between 100 and 1,000 metres deep, that scientists say is crucial for keeping atmospheric carbon dioxide levels 30% lower than it otherwise would be.
Just like the plants in your garden, phytoplankton, the plants in the ocean, absorb carbon dioxide from the atmosphere. The difference is that when these guys sink, they can go down into the deep ocean. And then the deep ocean, of course, isn't in contact with the air anymore, and so it's captured and it's stored down there for long periods of time.
In a bid to collect samples from this elusive region, they've built Pelagra, or the pelagic Lagrangian sediment trap.
So what this does is it samples the bit between about 50 and 500 metres. That's where a lot of the action is. We've got stuff sinking and there's lots of organisms that live there eating it. And what we want to know is what they're doing.
The device is carefully ballasted so that it will drift through the twilight zone, neither sinking nor floating, all the while collecting sediment samples through these rotating funnels. After a given time, it will release a heavy weight so that it rises to the surface to be picked up by the researchers. And this is what it's going to collect. Known as marine snow, it's comprised of dead plants, animal plankton and plankton feces.
Marine snow is composed of dead phytoplankton which sort of clump together to form flakes, and then they're heavy enough then to sink down into the deep ocean. It can also be formed by little animals which eat the little plants, and then they poop out that carbon, and their fecal pellets are very heavy and they sink down into the ocean as well, also carrying lots of carbon with them.
The team is preparing to embark on missions to the South Atlantic Ocean. They hope to better understand marine snow's importance in removing CO2 from the air. The research, they say, will also lead to more advanced computer models that could more accurately predict its impact on climate.